All righty, we are on the last class of geometry for the semester, the last class for the calendar year. And I was looking through the teaching textbooks curriculum, and in the around the 70s, we get to the trigonometry. So we want to get to about lesson 70. We're at 44 right now. So we're in really good shape. We're going to take our time. We're not going to rush anything. And we are rip roaring ready to roll. So what I wanted to do today is I wanted to have an abbreviated class. I wanted to go over some proofs, and I want us to do those together because it seems like we just didn't have enough time on the proofs earlier in the semester. We're at a little bit of a disadvantage to some degree, meaning we only have 2 classes we meet every week, whereas a more traditional setting would be 4 to 5 classes a week, or actually 5. And so with that being said, we're going to slow it down, make sure we understand how these proofs work, or at least better understand how the proofs work. Let me turn this down just a little bit on my, and there we go. Let me get to my whiteboard here, and we're going to do a couple of these together for surely, as many as we can do in about 30 minutes. We're going to have about a half-hour class here. And all righty. Let me clear this off. That was from earlier. And let's go to this, go to this. We want to be about a 5-point stroke. All right. So take your sheets here that I gave you. I think you got one of these. You're supposed to at least. This is number 22. This is actually a relatively difficult proof, okay? So some of them aren't as hard as this one. This is one of the harder ones that you've done. Okay, so I'm going to go ahead and turn this figure that they gave us. I'm going to turn it right side up, because to me it's always, they have it at an angle there. But I'm going to redraw it right side up just so I can look at it, okay? So they have MOL and T. Okay, this is what they've given to us. I want to step you through this nice and easy. And this is a little bit complicated, but I think we can understand it once we see it, okay? They said that MT is congruent to LT. They gave us that. And OT is a bisector of MLT, or MTL actually. They want us to prove that OT is perpendicular to LM. Okay, so again, we've not done enough proofs, so I get that they're a little bit hard for us. I'm going to step us through really, really slowly and just lay this whole thing out for you, okay? When you do a formal proof, you just do a little thing like this, and you make a statement, and you go to a reason. The last thing that you want to prove to say is the actual proof. So I need to prove, my last entry will be that OT is perpendicular to LM. So I can almost start backwards on proofs. Okay. I don't know why yet. I know what point that is. Okay. And I might erase that and have to bring it down a little bit. I'm going to go ahead and give me a little bit less of a stroke here so I can write. I'm going to go a 3-point stroke, so my pen isn't so thick. Okay. So this is what they've told us. Again, you're going to just make these points. You're going to put the graph on, and you're going to make these points. Okay, so the first one will just be all of the given. So you're going to rewrite all this. You'll say MT is congruent to LT, and OT is a bisector of angle MTL. And the reason that is because they've given that to us. They've told us that, okay? So now, this is what we're going to need to do. Let's think about this. I know a lot of you don't have your audio on, and some of your audio doesn't work. But they're asking me to prove that this line here, this line here is perpendicular to this line. Okay. So in order to do that, there's a couple things I have to prove. Okay. Now, in order for them to be perpendicular, they both have to be right angles, right? So this will have to be a right angle, and this will have to be a right angle. If both of these are right angles, then this is perpendicular. Okay. So there's I guess this is a very, very difficult proof. The next one's not nearly as hard. This is probably the hardest proof we've done all year, and we've not even done very many of them. Okay. So again, just kind of listen to what I say, kind of process what I'm saying. And I think this might even be a little bit beyond what you're able to put together. So that's one reason why I chose this one, because this is one of the harder proofs that you're going to do. Okay. So,
sorry, I'm late.
No worries. You're good, Corbin. We're just doing this one proof. It's number 22 on lesson 40.
All right. And the class start at 11 or 10:30?
It ended up starting at 11, so you're only 8 minutes late.
Okay, no problem.
Yeah, no
Thank
worries.
you.
We had a few people on at 10:30, but there weren't enough to justify it. So we just said, come back at 11. Okay. So this is what I'm going to do. This is going to actually be an 8-step proof. So my first step is this. Okay. So what I want to do is this also. I want to prove, first of all, that these two triangles are congruent. Because this is, again, I'm going backwards. I'm trying to prove that this line here is perpendicular to this line here. Okay, that's my proof. Okay, so in order to do that, I'm going to first prove that these triangles are congruent. Once I prove the triangles are congruent, I can prove these angles are congruent. And by definition, if two angles are congruent and they're on an even plane, don't they have to be right angles? Right? Watch. Because the measurement of a straight line is 180 degrees. And if there's two angles equal to each other, the only thing added up to itself to equal 180 is 90. So 90 plus 90 has to be 180. So if I can prove that these two angles are congruent to each other, then I can prove that these two angles are right angles. If I can prove that these two angles are right angles, then this line must be perpendicular to this line. Okay, I know there's a lot to process here, and let me step it through again. I'm going to take it nice and slow. As a matter of fact, I think what I'm going to do today is I'm only going to do this one proof, just so you can see how proofs work. The other one's a little bit easier, but I want you to see how this works. Okay, this is an 8-step proof. So let me explain it one more time. We've not done a lot of proofs. I'm going to erase this because I'm going to need more room here. Okay, so back to what I'm doing here. And I want you to pay attention. I know it's easy to get lost in all the terminologies and stuff. Just pay close attention. What am I trying to prove? I'm trying to prove that this line is perpendicular to this line. So I must be able to prove then that this angle and this angle are right angles. Because if they're right angles, then this line's perpendicular. Okay, so in order to prove that they're perpendicular, I have to go through a series of things in order to prove that. So now what I want to do is this. I want to say, well, what did they give me as a bait? Because they bait you with the giving, meaning they want you to take what's given and process what's given, okay? So they told me that this line is equal to this line, okay? So this triangle and this triangle share two congruent lines. I know that this line is going to be congruent to itself. They've also told me that this TO bisects these two angles. So I know that this angle and this angle are going to be congruent. Okay?
Mr. Sotos,
I know, I see it.
somebody's using my
I
name.
know.
That's not me.
I know. I know it's not you.
That's not me.
I'm getting rid of this person right here. It's a lame-os, man. Who does this stuff, man? It's like so stupid.
That's not me.
I know
That's
it's
not
not
even
you.
how you spell my name.
I thought you'd gotten booted out and then you came in with a different similar name. It happened last time before. Just like my goodness. Sorry. Yeah, I saw that. Somebody put I thought it was you. I let him in. I don't have to let people in, but I thought maybe you got booted off and I let you in. It's okay. Okay, so that being said, what I'm going to do is this. Listen carefully. I'm first going to prove that these two triangles are congruent. Once I prove that the triangles are congruent, I'm going to prove that these two angles are congruent. Once I do that, I'm going to state that they must then create right angles because they're on a plane. And then once I do that, I can say that this is perpendicular. So these are all the steps. My first one's the given. My second step is this. I'm going to say that this angle here, watch now, angle MTO is congruent to angle LTO. Okay, so I know that this and this are congruent. That's my first step. Because in order to prove triangles are congruent, I have to use one of like 5 different formulas that we've used before. Okay, so I got this is congruent to this as a given, MT and LT. I know that MTO is congruent to LTO because definition of an angle bisector. They told me OT bisected MTL, so then these two angles must be congruent. So I'm going to say definition of a bisector. Number 3, my next step is to just say that TO is congruent to TO. Because it's the same thing. That's just the reflexive property. Does anybody want to guess what my next step is? I don't want to do all the work for you, but who wants to guess what the next step is? I'll give you a hint. I have one line, one angle, and one line congruent on 2 separate triangles. So what's my next step? You want to guess? You can type it if you don't want to put your audio on if your audio is not working.
I can't really see the shared screen. I think I'm on the wrong page, so
Okay.
I don't know what's going on.
All right. So my next step is to now prove that these triangles are congruent. Okay. So how did I prove the triangles are congruent? Side, angle, side. So I'm going to say that triangle MTL is congruent to triangle LTO. So I'm sorry, MTO. Triangle MTO is congruent to triangle LTO. And watch how side, angle, side. So you put SAS. Okay. Again, we learned how to all those triangles and their congruencies. So again, I'm taking you through this slow, giving you these proofs. They want me to prove that this line is perpendicular to this line. So I have to prove that this is a right angle and this is a right angle. Okay. So if I can prove both of these triangles are congruent, then I can prove that both of these angles are congruent. And if two congruent angles form a straight line, then they must both be 90 degrees because the straight line sum is 180. And if they're both 90, then they're right angles. And if they're right angles, then it's going to be a perpendicular line. Okay. So my first 4 steps are to prove the triangles are congruent. My 5th step is to say that this angle, MOL, is congruent to angle LOM. I'm sorry, LO. I should say, I'm sorry, I said that wrong. So now what I want to do is I want to prove that this angle MOT is congruent to angle LOT. And remember that 5-letter acronym that we learned? All you got to say is this: corresponding parts of congruent triangles are congruent. Okay. Okay. Let me show you what we're doing again. From start to finish. Going very slow. No worries, Olivia. Again, my whole goal is to prove that this line is perpendicular to this line. Well, how do I prove that? I got to prove that this angle and this angle are right angles. Well, how do I prove that? I prove that these 2 triangles are congruent. I don't have enough to know that these are congruent yet, but I can prove the 2 triangles are congruent. Once I can prove the 2 triangles are congruent, I can prove that these 2 angles are congruent. If these 2 angles are congruent and they form a straight line, then they're a linear pair. They have to be the same measurement, so they have to be 90. Okay, so let me show you again. The given was my first thing. My next thing was to say that this angle, again, this angle here and this angle here are congruent because we're told that this whole angle is bisected by this, which makes these 2 right here congruent. This is congruent to itself. I know on the recording you can't see the cursor, so that kind of you can see it, but the recording doesn't show it. So the TO is going to be congruent to itself. So now I've proven the 2 triangles are congruent. Once I prove the 2 triangles are congruent, I can prove that these 2 angles are congruent because corresponding parts of congruent triangles are congruent. Okay. Then I can say that MOT and LOT are a linear pair by definition of a linear pair because of they are on the same line. Okay. So I got just one more statement to make, number 7. Okay. And number 7 is just this, that angle MOT and angle LOT are right angles. And the reason being is if 2 angles are a linear pair, then they're right angles. If 2 congruent angles are linear pair, then they're right angles. And now I've proven, again, this is a very hard proof. This is the hardest one we've done all year. That's why I'm doing it for you. That OT is perpendicular to LM. Just because definition of perpendicular lines. I'm gonna step it through the whole thing again, okay? I'm gonna show you again. Let me erase some of this stuff. A lot of this proof stuff, it just intimidates people. Okay. So what is my ultimate goal? To prove that this line here is perpendicular to this line here. Perpendicular lines are by right angles. So how am I going to do that? There's a couple different ways to do it, but on this particular one, you got to go with what they've given to us. So we take the given and we say, what are they baiting us with? What do they want us to do? Well, they told us that this line and this line are the same. They told us that this line bisects this whole angle. So they're baiting us to assume that these two lines, or to prove that those two angles are congruent. I know anything's congruent to itself. So they must be wanting me to prove the two triangles are congruent. Then I can prove these two angles are congruent. Then I can establish that they're on a linear plane, which makes them right angles. Once I know that this angle is a right angle, this is a right angle, then I've now proven that this is perpendicular to that. Okay, so side, angle, side, the triangles are congruent. So once I prove the triangles are congruent, I can now prove that these two angles are congruent to each other, because corresponding parts of congruent triangles are congruent. And since they're congruent, they must both be 90 degrees, because the only thing added to itself that equals 180 is 90. 90 plus 90 is 180. So they must be 90. If they're 90, they're right angles. If they're right angles, then this line is perpendicular to that line. Okay. Again, I just want you to see it. Let me just ask you this. After I talked you all the way through that, I know you probably wouldn't have been able to do it on your own. Maybe you could have. I don't want to insult your intelligence, but I know it's hard. After I walked you through it, can you see all the steps that I did in order to show that OT is perpendicular to ML? On the count of three, thumbs up if you can at least see it. Thumbs down if you're still completely lost. 1, 2, 3, go. Middle, okay. All right, anybody else? All right. Let's go to the next one. It's not quite as hard. Okay. Let me clear a couple of you. Saw it. You saw it. That's good. Anybody else? Y'all know Mr. So we're lost. Okay, here's our next figure. Looks like this. Okay, so we have A, B, C, D, E. A, B, C, D, E. Okay, they've told us that AB is parallel. No, I'm sorry. I read that wrong. Not AB. Oh, that didn't look right. They told us that BE, change colors here so you can see the contrast, that BE and CD are parallel to each other. That's the given. They've also told us that BE is congruent to CD and that AE, and this isn't to scale, by the way. I'm sorry, that's not. That this is congruent to that. Okay. They also want us to now prove that AB is parallel to CE. So what is my proof? That this line is parallel to this line. Okay, so let's go ahead and see if we can make some sense of this. This is actually a little bit easier of a proof, okay? And again, sometimes all this stuff just really, you can look at your diagram that you have there. I drew it for you, but you're gonna have to look for it on your own. Okay, so number one, I just say the given, which is BE parallel to CD, and BE is congruent to CD, and AE is congruent to ED. Okay, all that's given. Okay, we go back up to my line, okay, so what I want to do is this. I want to prove that this triangle here is congruent to this triangle. Once I've proved the triangles are congruent, I can prove that these angles are congruent. If I prove these angles are, let me get a little darker color here. If I can prove that these two triangles are congruent here, then these two angles will be congruent. And if these two angles are congruent, then these two lines must be parallel. Okay. So in order to prove that the triangles are congruent, all I have to do is say the angles here are congruent. Let me show you real quick. And then I'll say corresponding parts. And then I'll say that, then I'll make my proof. So now I'm going to say the angle BEA, I'll show it to you in a second, is congruent to angle CDE. Because two parallel lines cut by a transversal, we've learned that already, are congruent. We know they're parallel because they said they were parallel. They told us that these two lines are parallel, so that these two angles would be congruent. Okay? So BEA and CBE, BEA and CDE are congruent to each other. Now I can prove the two triangles are congruent. That's my whole goal, right? Triangle, look at it on your diagram. I drew mine, but you have yours is much cleaner and better looking. So as I write this, I want you to look at the triangles being congruent. Look at triangle ABE is congruent to triangle CED. And that's simply because we've proven a side, an angle, and a side. That's the three-letter acronym for side, angle, side. We have the one side congruent because they told us, the other side congruent because they told us, and then the one is the angles congruent because the lines are parallel. Okay? Then we just have to say that angle A and angle CED are congruent to each other because corresponding parts of congruent triangles are congruent. Once we've done that, we've proven that these two lines are congruent to each other. Then these two lines must be parallel because, so number 5, we made the proof now. AB is parallel to CE. Actually, I should say if two lines are if two lines, let me write this again a little bit better. I know it's hard to read my writing here. So. If two lines are congruent, and they're cut by a transversal, the lines are parallel. And I don't want to write all that. If two lines are congruent and cut by a transversal, their line is parallel. So let me do this. That's only a 5-step proof. I'm going to erase all this and I'm going to step you through it again. I'm going to redraw our diagram and we will show you exactly what is going on here. A little thicker. Go back to black. Okay. Okay, so what we need to do is this. Again, back to what do we prove? What do they want us to prove? They want us to show that AB is parallel to CE. Okay. They told us that BE is parallel to CD. They also told us that BE is congruent to CD, and they told us that AE is congruent to ED. Okay. So what we want to do is this. We want to prove these two triangles are congruent to each other. Once we've done that they're congruent, we can prove that these angles are congruent to each other, which is A and CED, that this angle here is congruent to this angle. And once we've done that, then we know that the two lines are parallel. So our whole goal is to prove this right here. AB and CE are parallel. So I state my given number 1, which is what I just did. Number 2, we're going to say that BEA and CDE, so BEA, CDE are congruent. The reason we know they're congruent is because we are told they're parallel lines. Once we've proven that, we can say that the two triangles are congruent to each other. So ABE and ECD, these two triangles are congruent because of side angle side. Once we've done that, we can say that angle A and angle CED are congruent because they're corresponding parts of congruent triangles. Once we've done that, we know that AB is parallel to EC. Why? Because if two lines have, if a transversal that cuts two lines, if the two angles are congruent, then the two lines are parallel. So it's a 5-step proof. Okay. The first one we did was an 8-step proof. This is a 5-step proof. Again, let me show you. I'm going to write it all down for you. And I want you to look at it on your sheet. My statement and my reason. 1, 2. I'm sorry, 1, 1. Number 1 is this. All the given, you just say it. BE is parallel to CD. They told us that. BE is congruent to CD. They've told us that. And AE is congruent to ED. So they've told us that two sides are congruent. They've told us also that two lines are parallel. That's all given. Because that's what they've told us. The conclusion that we can draw is that we need to prove the angles are congruent. So we say angle BEA is congruent to angle, look at them as I say it, CDE. And that's simply put, because if two parallel lines are cut by transversal, then their corresponding angles are congruent. They told us they're parallel. So you have two angles of parallel lines are cut by a transversal. They're congruent. I won't write all that down. So I've proven that these two lines are congruent. So now I can, two angles. Now I can say the two triangles are congruent. So triangle BEA is congruent to triangle CDE. Because we got two sides and angle, so we have side, angle, side. Boom, boom, boom. Because those triangles are congruent, their corresponding parts are congruent. So we have angle A is congruent to angle CED. Because corresponding parts of congruent triangles are congruent. Since we know that, then we know that AB is parallel to CE. It's the opposite of this. This tells us if two angles of parallel lines are cut by a transversal, then those angles are congruent. Now we're saying if the two angles are congruent, then the lines are parallel. So it's basically the reverse of 2. Right? Because here they told us the lines were parallel, so the angles must be congruent. Here we said the two angles are congruent, so the lines are parallel. Because A and C are congruent, CED are congruent to each other. Okay? So I'm not going to write it all out, but it's basically this, but in the reverse. Okay? So basically, if two angles are congruent and they're cut by a transversal, then the two lines are parallel. All right, so the reverse of 2, I'll just put. All right. Again, I know these are not the easiest thing we've ever done. I just want you to see them. I'll help you with them. And we're going to go ahead and stop right there with just those two proofs. I know it's probably easy to get lost, and I'm just what sounds like just spewing mumbo jumbo. But we'll step you through them. I'm going to record this. I am recording this. I'll upload this on the YouTube channel. If you want to see it again, we'll maybe watch it again, and then we'll jump into more constructions. We're going to slow down the second semester quite a bit. We only have to do like 30 some more lessons. So we have 15 weeks. So at the max, 3 per week. Most weeks, just 2 lessons per week, as opposed to 4 that we were doing before. That way we can do lots of constructions together and really just digest these proofs that we've been learning. All right. But other than that, been a great semester, and we'll see most of you. Lots of fun constructions, and we'll slow it down a bit. It'll be I think a more enjoyable second semester. I know we got kind of overloaded first semester, maybe doing too much too fast. We're going to slow it down a little bit, make sure we understand these things, and we'll call it a really, really good second semester. But anyways, have a good 3 weeks off, and we will see you January 7th, 2025.